One, two, one, two. Hello, everybody. So we meet again. So this afternoon we are going to talk about chapter number 2 because last time we had a lot of things that should be finished but not, and we're going to continue the chapter number 2, and we should end at the send message part, right? Send message. So let's see the corresponding pages of this one. Okay, so we should be ended at here. I think last week we shared the information about how to make the red method calling, and we know send message could be used as a way for broadcasting. So that is a very basic means for you to notify other than object if you have any message to send. Okay, great. So in the lesson of this week, the first thing we're going to talk about is delegate. Delegate is not a basic idea. Delegate is an advanced topic if you're learning C sharp. So please pay a little bit more attention to this part because this is not a fundamental part, fundamental C sharp knowledge. This is considered as the advanced knowledge. So delegate is used for example, if you have an idea, you know a rough idea about a feature of a object, but you didn't know how to implement the function right now. If this is the case, you have the goal for this method, but you didn't realize the real code at this moment, then you can put the method as a delegate in order to implement the real body someday later. So that's the purpose why we put so many delegates in the object, and we're going to implement the real content later, or maybe 1 month later. But what is a delegate at all? Let's see the introduction page over here. Okay, this is the definition of delegate. A delegate is a type that represents reference to method. It's a reference to method with a specific method signature and the return type. So let's take this line as an example. For this line, we declare and define. So we just declare a method called add, and the method add has only 3 different arguments that they are listed over here. So the first argument is an integer. The second argument is an integer 2, and the third argument is an array of integer. So this regulates whatever in the body of the method. It always have these 3 arguments, right? So that's the purpose of delegate. You just regulate, and you have to put all these 3 arguments some days later when you implement the body. So this is the purpose of the delegate. And somebody may ask that, Mr. Fu, so how about the return type over here? We see that the return type of this add method should be integer. So is this part of the definition of the delegate here? Sorry, of the signature here? So just like we said before, a signature just is just composed of the settings of arguments. A signature does not include the return type. So this is the definition of a signature. Okay. So let's go back to the definition of delegate. So of course, a delegate is composed of a method signature and the return type. So this is what we meant over here. Okay. All All right. So when should we use delegate to regulate a method? All right. Here comes the use cases. The first case is event handling. So delegate are commonly used to define an event handler, just like we see before. For send message, we have some trouble because send message only carries one argument, right? And that's the only argument should be type of object. So this to a large extent limited the purpose, limited the usage of send message. So if we must pass much more than two arguments to the message body, we have to box box the arguments into one object. So did we talk about the boxing and unboxing things before? And so let me have a sketch for everybody. Okay, if you search the keyword boxing and unboxing, boxing and unboxing in C sharp. So this is a very well-known uh, very well-known operation in C sharp programming. This is we can turn this into English because the default language for this browser is Chinese. All right, so this one. So let's talk some little things about boxing and unboxing. So we know that sometimes we are limited to pass only one argument to our message body, only one argument. But actually, for the purpose, we should pass much more than two arguments to our message body. So what would be the workaround? What would be the solution? So here comes the solution: boxing. Boxing in C sharp. If we have a series of variable, for example, my name and my age, maybe the brand of my car, and some private messages over here. So this is a list. Da, 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 da. But I want to pass so many variable as arguments to my message body, but my delegate only allow me to pass one. So what should I do? All right, so I can use a general purpose data type, which is called the object is C sharp object. And I can take the whole things together and treat this collection as one object only. Here we have n variable, but after boxing the data type, I can treat it as a whole integration of the variables. So this is the concept of boxing. So in order to uh, unpack the object back to the data collection, I have to do the unboxing procedures. Unboxing. So this is why you see an uh, an object class conversion over here. This is an implicit conversion. You just convert the integer 10 into object. Sorry, this is explicit conversion because I clearly put what should be the destination type. Destination type should be object type. So I just convert a 10 into an object. So this kind of conversion is boxing. But please be noted that even doing boxing could make your message body compatible with your signature, but it will cause some garbage in the heap. And did you remember the difference between stack and the heap we were talking about before? All right, so this is the memory footprint of a program. We have a stack memory from bottom to up. As long as you increase your number of callings, you are stacking the variables towards the top of the memory. This is stack. On the other hand, there is another allocation called a heap. The heap is growing from top to bottom. So whenever you call a method, you just push your arguments into here. And whenever you leave the method, you just pop the variables and free the memory over here. This is push and pop of the argument passing. But if you create a new object by using the new operator, a new a like this, bah, 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 then you are creating an instance of a, right? Typically, we may declare an a, which is a type of a, and just use the new keyword to instantiate a new a. So this a will be put in the heap. And if you leave the body, if you leave the message, the method body, the A is still over there. You have to manually release the memory. Otherwise, the instance is always existing in the heap. So that's the problem. When you do a boxing things, it will create some garbage in the heap. So this will create some garbage in the heap. So what should we do? Actually, you don't need to do anything because C# has a garbage collector which will automatically collect the garbage for you. It runs periodically. So I love C#. The same thing happens to Java. Java also has a garbage collector. We call this kind of things a runtime or virtual machine. Java has a virtual machine, C# has a runtime, and garbage collector is one part of them. So this is garbage collector. All right, so this is a supplement for the content of last week. So let's move on to the next topic. We're going to talk about the delegate. So coming back to here. So the first case for the utilization of a delegate is event handling. It can regulate the signature of a method. So the second case is callback method. If you make an asynchronous call, which we are going to talk about next week, the asynchronous call could have a callback. That means when the asynchronous task is finished, it will run the callback automatically. But before it runs the callback, you have to regulate the argument patterns. So this time you need delegate again. If the argument does not compatible, that will be a fatal error because the calling will be a mess. Since all the arguments are not compatible together, this will call this will most call malfunction. So the second case is callback method. And the third case will be similar to the second case. The third case listed over here is multi-threading, of course. And the fourth case is encapsulation of method call. Sometimes we just have some we have some need to regulate the type of arguments. We call these things encapsulation. So of course, delegate can help me to encapsulate the method calls. Okay, this happens to whenever you are design a plugin. Do you know plugin, the third-party plugin? Yes, we can download so many third-party plugins from internet. Imagine that you are a plugin designer. You are designing so many API methods by your own. So the most important thing is that you write a rule for your customer to call your APIs. And you have to clearly address the need and the purpose of each of the arguments. So again, you need a delegate. So in order for your customer to correctly use your APIs, you have to encapsulate your method codes. All right. So let's have an example for delegate. So let's look at the codes over here. Nothing special. The only different thing is over here. We declare a delegate over here. So we call this delegate a my delegate. We can think that the my delegate is some kind of rule to regulate some method. So we see here the my delegate requires that the first argument should be a string, and the second argument should be an integer, the third argument should be an integer, and the fourth argument should be an integer too. Okay. So it regulates its pattern of the arguments. So let's see the following codes over here. On line number 11, we use this delegate to regulate my new method, which is called myDeler. MyDeler is a new method, and I have to regulate the pattern of the input arguments. So you can see that I create a new delegate, and the new delegate is Showtime. All right, Mr. Fu, who is Showtime? Okay, wait a moment. Let's look at the bottom of the paragraph. Ah, Showtime is over here. So did you see that? This is a real method body. The real method body is over here. The Showtime has a real body. And by the way, the Showtime has an identically the same signature to the my delegate. You see that? The Showtime has a string and the three integers as its signature. This is the same to the my delegate. So what if we remove any one of the argument of Showtime? All right, if you do this thing, it will cause a fatal error and the code will not compile. So later, we're going to finish the code here. And after you finish all the code, please try to remove one of the argument over here and you can see the fatal error. Okay, all right, so let's do it. Let's spend about 5 minutes, 5 minutes, okay, to copy the code into your Unity. The page, the page 11. Okay, I need your focus over here. Because last week we found some error from the local class. Somebody have two classes with the same name in this project, and that will cause a class name confliction. So in order to get rid of that, we can use a namespace. Sorry, namespace. For example, I can declare a namespace of delegate and within the namespace we can put several classes, and if you want to reference to the classes to the class in the namespace, you have to using delegate dot x delegate to like this one. Maybe I shouldn't use the word delegate because it probably in the namespace chapter 2. Okay, chapter 2. So whenever you need to refer to the class over here, you have to use the whole reference address from chapter number 2 and X delegate like that. Okay, this will refer to the class over here. Uh, wait. What is that? Message or read second message. Second. Message the title is Oops, where's the line number? Okay. Ah. Because line number is a very important information when you are reading code. So um, in line number 30, you can see that this works too. If you are going to declare or assign the delegate body, you can directly use the equal sign. You can assign the method with the real body to the right hand side. This is your variable, this is your reference, your delegate reference on the left side. So okay. All right. So you may wonder that I can just call show type at any place. So why bother with the delegate? Why do I need to assign a delegate and call the delegate? What's the benefit and advantage of doing so? Okay, the advantage will be like this. Next, we can reassign the body of a delegate. So let's look at the code over here. We declare a my dealer over here, and we assign a delegate to it in line number 10. But we reassign the content of my dealer in line number 14 over here. And this will cause the behavior of my dealer to be totally different. Let's look at the output. So whenever we assign show time to it, it can show the message and hour and minute and second. And whenever we switch the body of delegate to an alarm setting over here, look, the alarm setting also needed a setting for hour, minute, and second, but the message is different. The message is when the alarm is taking effect, it should be shown on screen. For example, this is an alarm for waking you up in the morning, so it will show wake up in the morning. So even the signature is the same, but the purpose of the design of the method is different. One is to show the time right now, and the other is for setting of your alarm. So this is a very nice example of how delegate can bring some advantage to us. So now I need you to write the code over here to append the method of show alarm settings over here and try to reassign the delegate in line number 14. Okay, let's take about 5 minutes to do the task. Okay, if you never use this kind of string assignment, let me have an explanation. The D2 means here it just regulate to a two digit of decimals. already, and you can have your time. I just want to have something for family or together. Sometimes you know that when we are implementing a framework or program or your application, um, some concept method will not be implemented when you are making prototype. Just a prototype. But you still have to make some method with antibody at this moment. Some later you're going to have or to have a trial of this method. So you can put an empty method at this moment when you are making code, and later you're going to fiddle around and maybe try some experiment with the method body. And sometime later you may implement the real body code. So an antibody method does not mean nothing. An antibody method is very, very important when you are making a prototype. You have to make an empty method for and sometimes it just try to load some message to the console. Like right now, need to be implemented next week. And one of the location for delegate is that you want to make a task. Although we did not talk about the unit test right now, but I'm considering to show you how to make all the unit test several weeks later. And when you're making a unit test, you are testing a special version of your method. You have to make a special version. That version is only for tests. And when you pass all the tests, you back up to the original version of the method. So that is if this is what you need, you can delegate. Okay. So as a supplement for everyone, this is the purpose of delegating. All right, so I think everyone finished the delegate exercise over here. So let's now move on to the next page of slides. Okay, the last topic we are going to talk about for delegate is multicast of delegate. We just assigned a single method in the previous examples, but right now we're going to assign multiple methods into one delegate. So we see the codes over here. In line number 10, we assign a delegate del, and at the first time we just assign show message one as its only body. So you can look here. We assign show message one to delegate. And later in line number 13, we add another method into the delegate. Okay, so you see that we simply use a operator of plus and equal over here, and this can append a delegate with a method. So if we invoke the delegate in line number 16, you will see two lines of output. The first line is message one, and the second line is message two. So very interesting. So we call the behavior of line number 16 a multicast. This is multicast. So later we see that in line number 19 over here, we just subtract, we just remove the show message one from delegate. Okay, so we can append and we can remove. By appending, we add a more method to one delegate, and by removing, we just delete more method bodies from the delegate. So this is how we add and remove. So after that, in line number 22, this time we call the delegate again, and that will only invoke the message two. Okay, so let's take about 5 minutes to finish the code on this page. Okay, I think most of everyone has finished the code over here. So let's close the topic of delegate and move on to the next one. Okay, so the next topic is events. The reason why we talk about delegate before is that because delegate is the fundamental of events. Actually, somebody think delegate and events are so much similar, and they could be replace each other. Whenever you need a delegate, you can always replace the delegate with an event, and vice versa. So, what is event and what is the purpose of using an event? Okay, let me have a comic for everybody. Have a comic sketch over here. So, you do you have a PlayStation 4 or do you have any arcade or any console video game machines? All right, so this is a controller. Sometimes you have several different characters in your game. This is a robots, robots. So you have to use your controller in order to control the robots. So you send message to the robots. On the other hand, there is another character who has a human type shape. Okay. Sometimes you want to control this character, and maybe sometimes you want to control a car. Want to control a car in the game. Yeah, this is a car. You want to control the car. But no matter which one you are trying to control, you are always using the same controller, right? You never change your controller. You use your PlayStation controller to control everything in this game. No matter if it is a robot or a human or a car, they are all compatible to your controller. So how to do that? How to do that? So whenever we're making a code, the code structure will be like this. Here we have a hook. We have a hook, and this is the robots. All right, robots. Okay, it's robots. Oh, oh, okay. So you can control the moving direction of this robot, and you have four different methods over here. They are up and down and left and right. So you have four different methods, and you already write the code for this robot. It moves just perfectly. And we know that this is your controller. You also have four buttons over here. Maybe they are up, down, left, and right, right? So the mechanism will be like this. Whenever we press the play key on our screen, the robot is instantiated. It just appears in the game world. And suddenly the robot just hook his method, just put all these four methods onto the hook. And it just finished the hooking process. And after that, my controller can send some message. If the up button is pressed, it just send a message. Oh, the up is pressed. Then I'm searching which one is belongs to this corresponding message. Ah, you are the one, and it just call the up on the robot. So whenever the key of D is pressed, it just send another message that oh D key is pressed. So who is D? All right, you. This guy is the D method. So I just call it D method for you. And later, if I'm going to switch the character to this little human, and this will be pretty similar things. Pretty similar things. So this time I have a human character. This is another character, and he also has four different methods: up, down, left, right. And when he is awaking, he just bind all his methods. Sorry, I should use red color. Bind, 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 and bind. So if somebody press the U key, so this time two methods will be fired because this is corresponding to another U method, so this will be fired. So if you hook all the 8 different methods onto this hook, and both of these two characters will be controlled by this controller. So you can see that when you are pressing the up key, the up arrow, both of these two characters are moving. So this is the idea of the event. So what if I just want to switch the character from robot to human? That is simple. You have to unbind, you have to unhook all the red lines over here. So if you unhook all the red line, that means you remove all the event handler. We call this event handler. All the event handlers are removed, and the robot will not act again. So, do you remember the event handler? Yeah, event handler. So you can use delegate to serving as the event handler. All right. So if you can understand, later we are going to implement the whole thing on this picture. We're calling this little box event center. Event center. This is an event publisher. Publisher. And these little guys are event subscriber. Subscriber. So this is the subscriber pattern in design pattern. We talked about the design pattern before. This is a real pattern which is addressed in the very famous book design pattern. You can find this pattern as subscriber pattern. Okay, let's go back to the PowerPoint slides. Oh, sorry, right now it's 2 o'clock, right? Well, before we talking about the event system, let's have a 10 minutes break, right? Okay. See you 10 minutes later. Okay, this is oh uh-huh. Is it a Euro connector or USB charger? Okay. Mm, charger. Yeah, I have a charger. So, do you have a line? Do you have the cable? Because my connector is micro USB, so if you can. Mm, looks like you did need the. Very short. I think this goes together. Mm,
Okay.
okay,
Okay.
try it.
Okay.
Okay, welcome back. So, we just explained why the event system is very beneficial for a game or a application. Actually, if you have some experience about Android programming, let me see, Android, the button events, and maybe we can find some clicking event handler. Uh, activity send message. Okay, this one. No, no, not this one. Okay. Okay, if you have some experience about Android programming using Java, probably you implement some button before. So this is a very common and classic structure of making an on-click call. And you can see that this is the event when your application is created, and at the same moment it just set the whole UI things. It just read a list, and the list address all the UI elements on the screen. And by calling the set content view, you can set the whole UI screen. And after that, you'll have your button. And after that, you can find your button by some fixed ID and use the set on click listener to bind your method body. So this is hooking some method onto the center. Set on click listener. So set listener is what we shown over here. Whenever you assign a method body, uh, also we can call it the hooking process. You hook any method onto the center, and it's identically the same to the set on click listener. So after that, whenever somebody is triggering the button, you'll receive the on-click message, and then this, and then the on click will be called. So this is the send to the Android message system, but the detail is a little bit different. Okay, so today we're just going to implement the vanilla version of the event center. Okay, let's go back to the PowerPoint slides. So what is an event? Actually, in C sharp, the event is to provide a notification to other class or object when something in interest is occurring. So events are based on the delegate model. Okay, so event and delegate typically they are the same things and provide mechanism to broadcast a message to multiple subscribers. Okay, the second one is event actually uses the publisher subscriber pattern. So this is what we have introduced in this picture, publisher and subscriber. Okay, so the usage is the same to the delegate. The first usage is to serve as the event handling, and the second usage is to decouple the codes into several modules. So in this picture, we decouple the whole feature into three different roles: the publisher, the subscriber, and the center. The responsibilities of these three roles are different. So this is a very nice example of decoupling. Decoupling. And the third case is asynchronous programming. And we're going to see how this can facilitate the asynchronous programming next week. And the fourth usage is real-time updates. The event is really fast comparing to the polling mechanism. Event is considered a faster ways for notification. So commonly, you will see we use events in UI design and use and some usage for custom notifications, uh, like you are implementing some game event system, and you can use C# event as your structure for your event system. So the number three is asynchronous task completion. When some asynchronous task is completed, you can send events back to the main threads. Okay, next. All right, so let's implement a C# event. And we see that in the red one mark over here, we still have to declare a delegate before we use events. So we see that we declare a delegate, which is called my event handler. And we use this delegate to declare a new event. So whenever you need an event, you still need to declare a delegate. That's why we talk about delegate in the last hour. So we can declare an event by the delegate, like here. And next, let's describe some method bodies over here. So we design a subscribe and an unsubscribe method over here. So this is the code of message center, sorry, event center over here. Whenever somebody is calling subscribe, they can pass some handler to this event center. So we can see in the line number 18, when somebody called the subscribe of center, he can hook some delegate onto this center. So here is the delegate. So for event, it's very simple. You just need to append the handler onto the event. And on the opposite, let's see the line number 24. Our center also has an unsubscribe method. So if somebody is calling the unsubscribe of center, then somebody can remove certain handler from event system. So this is what we can find here. But if somebody is willing to invoke some event in the center, then he can call the invoke method on the event center. So we can see in line number 14, this line just call all the event delegates which are binded to my events. And you may ask that, Mr. Fu, why we see a question mark over here? Okay, this is a very special sentence. Whenever you put a question mark before the dot, and this question mark will enforce the program to check whether the my event is null or not. So if the my event is not null, it just execute the following codes. On the opposite, whenever you see a question mark, it will it will distinguish. It will try to figure out whether the my event is null or not. But if the my event is null, then it will just pause it here and do nothing. All the following things will be dropped. So this is the purpose of the question mark over here. All right. I may not use this question mark before, but sometimes for convenience, I will write the code like this. Otherwise, you're going to need an if judgment. You need an if condition. That's too that's too tedious for me. All right, so let's spend about 5 minutes to finish the code on this page, okay? Sorry. Please pause it here. This code will not run because this code just contains the part of the system. We just finished the center part. We need to move on to next part. And next, let's implement the the code for subscriber part over here, like the robot and the human character. So in line number 17, we see another class, which is subscriber over here. And the subscriber definitely need to know who is the center. So that's why we put a line number 5 over here. We can bind the actual instance of center in Unity editor. So we just expose the variable, the center, to outside. And next, you see that the unenable is a Unity lifecycle API, which will be fired when the game starts and the object is enabled. And in line number 12, you see a Unity API, which is undisabled. This method will be fired automatically when your Unity game is terminated, is paused or stopped. And of course, the object has to be disabled. So whenever the object is enabled, this object, I mean the subscriber, automatically subscribe its event onto the hook of the center. So on the other hand, if the game is paused or for some reason the object is disabled, it just automatically unsubscribe its handler from the event center. So what is the real body of the method? We can find the real body from line number 16 over here. Okay, the real method body having a name of handle events, and the real body just contain one print message which shows the event handle. Okay, so these are everything inside the subscriber. The most important thing is that this just automatically hook all the handler onto the center when when the object is enabled or disabled. So this is very interesting. It just do it automatically. Okay, next. So after we finish this part, we are going to spend about 5 minutes to finish the all three little things on this picture. So the third part of the code is the publisher. So of course, for publisher, it should know who is the center. So we see that we put the line number 5 over here. So we can assign an instance from Unity editor to show who is the center. And next, let's see line number 9. Line number 9 just capture this keystroke of A. So whenever some player is pressing A, line number 9 will be executed. And if this is the case, line number 11 will also be executed. So we see that line number 11 just let the center to call invoke. So what is invoke? We roll back to the program of the event center. In the invoke, it just invoked my event. So some days later, if you have multiple events, probably you have to assign which is the correct event you want to invoke. At that time, you're going to add one more argument in it. But right now, let's keep it simple. Let's assume that there's only one event belongs to the event center. It just can allow one event. All right, so let's use 5 minutes to finish all these three parts of the system. Okay, if you finish your part, and I'm going to have an example for everyone. So as you can see here, I created three different game objects, and one of them is called center, and one is called subscriber, and the rest one is called publisher. So if you would like to add a tag like this, you can select any of the object and look at the inspector over here. So on the top left corner, there is a drop down list. You can select the style of the icon over here. So you can select any one of it. So for me, I select the red yellow icon for center. So it will be like this. So if you like the tag to be shown bigger, here is an drop down list, and on the top there are some sliders. You can enlarge the 3D icon value by dragging the slider. Then you'll have some bigger character shown on the screen. Okay, so I just attached the center code to the center and attach the subscriber to the subscriber and attach the publisher to the publisher. And one more thing to do. We have to bind the center instance into correct field. Let's list subscriber first. We see that for the subscriber, it has to know who is the center. So we are going to assign the center to the variable. By simply drag the center object in the list on your left hand side, click and drag, you can assign the center to it. Please be noted that the whole process should be done in once, because once you release your left mouse button, everything will turn to the different UI screen. So you have to press and drag and release. Okay, so do the same thing for the publisher. We have to assign center to the publisher. So after the assignment is done, let's click play. So after you press play, you have to click once for the game window. Otherwise, the focus will be will be not correct. Okay, and after you click for once in the game window, you can press A. Sorry. Whenever you press A for once, you'll see another new log message in the console window. Okay, the most important thing is that if you duplicate the subscriber, select the subscriber, press Control D, you can duplicate a new one and drag the new subscriber to some places else. Like me, I just duplicate the subscriber to 3, and if I press play, and this time whenever I press A, I get 3 messages. Every time I press A, I just get 3 messages because the 3 messages from different objects. So if you would like only one of the 3 objects takes responses, you can just unbind the center instance from it, and that means that he will never know who is the center, and the following communication is not possible. So I just remove the setting of center of subscriber 1 and 2. And as you can see that the binding process goes some error. So it had difficulty to register to hook its method body onto the message center. So if you don't like to see any error message, we can modify a little bit from the subscriber code here. the subscribe. So you can put a question mark before you call subscribe. So that means whenever the my center is null, it just do nothing, and it won't execute any of the following codes. Okay, so if you have some experience about playing a special kind of game, um, you can use your controller to control two different characters in the same screen, but sequentially. And for example, there is one boy and one girl on the screen, and you have to control the boy in order to unlock some door, and you switch your control to the girl, and the girl can pass the door, and to help each other to find the final exit of the room. It's like something like escaping room game. So I think you can find some example in the market that you should switch between several characters to finish the level. Okay, so if this is what you are going to do, and event system is one of the consideration you may have when you are choosing your architecture. Okay. All right, so I think probably some of you guys are still trying to finish the code. Okay, let me have some additional supplement for everybody. So we're going to skip the next two page because next two page, I think, by simply explain the idea behind, you should be enough for you to get the idea, get the whole idea. All right, so the problem is like that. Whenever we assign a new event to the system, the number of events just grows, right? For example, we design the up, down, left, right for a human being. We design a forward and a backward, accelerate and decelerate for a car. And we design so many different events for different purposes. So you can imagine that there are so many handlers to be hooked onto this hook, right? So the number of handlers would be an enormous number. That is a little worry for me. So can we lower down the number of events that it has to be dealt? Sure, no problem. You can lower down the number of events by simply group some similar events into one. By grouping the events together, you can lower down the required number of events. So the benefit is that the system will become simpler to be understand and be maintained. And for example, if you and your colleagues are trying to maintain this system, if the number of events grows too large, that would be a difficulty for all the maintenance colleagues to fix the problem of this system. So lower down the event is one of our goals. We don't want like the system to grow to be too complex for us. If this is what we are going to do, then we can pass another arguments to the event center and all the other two little guys in order to multiplex several events within one event. So this is the solution for it. Let's take a look at page number 19 over here. So in the previous code, we didn't send anything. We didn't send anything to the event center. Now I have an idea. Whenever a robot is trying to hook any one of the handler onto the center, it just pass a delegate like this, like this. The delegate shows next time if some publisher is trying to send something, the publisher has to mark himself as a sender. Can you get it? The robot is trying now to hook some handler onto the center, but this time the handler has a different signature. The signature requires the publisher to identify himself, identify himself. So the first extra argument is who is the sender. Okay. And the second new argument is what is the sender trying to do. So for the adding of these two extra arguments, the handler should have a mean to multiplex his methods. So if the controller is PS4 controller, then I will respond to the controller. Okay, now you are a PS4 controller. I identify what you are. And if you are a PS4 controller, you must have an up key, right? So next time if you are pressing an up key, I as a robot will go up like that. But sometimes we are going to hook some other shape of controller, like a wheel. You see a wheel device for the racing car game. This is a wheel, and the wheel only takes its rotation as a data and pass it to the device center. Okay, this is the rotation angle of the wheel, so we adjust the event of maybe angle change or something like that, angle change. But as you can see that angle change is totally different to the idea of up, down, left, right. So next time when you distinguish that, oh, the publisher just published a message, but the publisher is a wheel. The publisher is not a controller. So if this is the case, the robot will just neglect what it received. So by adding these two extra arguments, we can bundle so many different messages into one system without making it without making it to be too complex. All right. So if you have some experience about Java programming for Android application, you must see this signature before. You should have seen this signature when you program for Java application. Uh, right now I have difficult to find some reference code on internet. Let me see. Java button example. Android Java button event example. Sender and the argument of events. Nope. Okay, maybe this is too simple. So we just use a simplified version of event handler. Unity button. Unity button handler. All right. I'm sorry, I can't find any example right at this moment, but we're going to try to find some example later. Okay. Okay. So this is the two new arguments over here. So after we modify the delegate, you can see that on line number line seven, line seven. This is where we declare the delegate over here, and we just added two new arguments over here. So that means we have to modify the corresponding method body. So we know that the real method body is listed, is addressed in the subscriber. So let's go to the subscriber, and here is the real method body. Of course, we have to modify the method. So we just added the object and the event arguments we need over here, and this will make everything compatible again. All right. So when the publisher is trying to publish the event, it also has to pass the two new arguments. The first argument is himself. So you can see that in the line over here, the publisher just passed himself to the event center. So we know that the publisher itself is this. This represents for the object instance of the execution object. So who is the execution object? The publisher. And the second argument is event argument. So Unity just provide this class for us. We just need to generate an empty blank new object over here, an empty event arguments over here. You can have your proprietary event argument class, but right now we're not going to do so. Okay, so let's have a summary for the parts of events. Okay, so the first thing to be addressed is the key differences. So there are four differences we see in the example. The first difference is access control. For the delegate, it should be public, and it can be invoked by any class with access to the delegate instance. And for the event, it can just be raised within the declared class. So what does it mean? So, all right, this is very important. Did you remember the invoke? The event invoke this API could be only executed within the event class. Sorry, within the center class. But for the delegate, you can call the delegate at anywhere you are at. Where is the delegate? Oh, in our example, we call the delegate within the same class, so it doesn't show the power of delegate. Delegate is really powerful. You can take it as a common method. It's just acting like a common asset method. So you can call a delegate anywhere from anywhere. But for event, you can call invoke anywhere. You can just call the event as a so here it is. Calling an event is restricted. It can only be raised within the declaring class. So where you declare the event, that's in that scope, you can only invoke event over there. So in our example, we can just invoke the event from line number 6 to line number 28. So event is much more safer. And second thing is the encapsulation that is different to delegate and events. For delegate, it is directly accessible and invocable. So this is just like what we talked about in the last point. And for event, it provides a layer of encapsulation. So it's just limiting the invocation of the declaring class. So the point number one and point number two, they are really similar. For the third difference is that the usage scenario, the delegate is used for callbacks and method references. And the event is typically used for notification and signaling state changes. So when you need a whole system like what I showed in this picture, for this kind of application, we're going to use events. But for some simpler using scenarios, we are considering to use delegate, and that is pretty simple and fast and usable. And so event and delegate, one is for bigger use and the other is for smaller use. Event is for bigger usage, and delegate is for smaller usage. This is not a must, but this is a very common rule of thumb. And the last one is multicast. Both delegate and events support multicast. You can invoke multiple methods at one time. And the return value of multicast delegate will be the return value of the last executed delegate. Okay, this one is really interesting and important. So if you have a multicast delegate, the return value will be the last executed delegate. Interesting. Since the order of execution is not guaranteed, it is suggested that to the use of to use void as the return type for multicast delegate or event. So this is very important, just like in the first page of the slides. The delegate, where is it? Did you remember the red color over here? I intentionally marked this return value as red color. Why? The, the purpose is not to use the type of return value in your design because the order of execution of event and delegate are not expectable. It will be random order, so you will never know who is the final one, who is the last delegate, who is the last method that execute at the last. So the return value is totally not predictable. So that's why a signature doesn't contain the type of return value, and I suggest always use void as the return type of a delegate. Always use void as a return type of a multicast delegate or event. Okay, for multicast, the reason why is the order. All right. So conclusion: delegates are more flexible and can be used in a wider range of scenarios where direct method references are needed. So delegate is almost pretty similar to a method, but the event is the encapsulate of delegate. So an event has much more limitation. Just like that, you just can call an event, you just can invoke an event within the declaring class. But that is a good behavior. We wish to have it. So events provide a more controllable and encapsulated way to manage notifications and state change, making the ideal for publisher and subscriber pattern. Okay, great. I'm sorry, I should have started a coffee break. No matter, and we can have a 10 minutes coffee break. Okay. 我把我画面输在上面好。
center 那 center 在哪里？
像这个例子，我们就是一个脚本放一个物件，那我就造了一个 center，一个 subscriber 跟一个 publisher。那 center 身上要挂 center，publisher 身上挂 publisher，subscriber 身上挂 subscriber。但是 publisher 跟 subscriber 只需要知道 center 是谁。
他们必须是不同物件吗？
也没有啊，这样看起来比较清楚。其他的应该是从组变。有时候我们确实会把两个人绑在一起，那是另外一种模式，我也常用，也不绑跟绑都可以。对对对对，就塞 center，就谁带 center 就把它塞进去。对对对。如果说 no reference 就是漏词。那先点一下画面在那边。没有 public，它就没办法从编辑器里面配。 Okay, so let's go back to the class. Okay, so in the last hour of this lesson, we're going to combine everything you learned in chapter number 2 and have a full understanding and comparison between the four different means of implement a method call. They are they are direct method calling, send message, delegate, and event. But before that, let me introduce a C sharp version, sorry, a Unity C sharp version of event. So this is it, the Unity event. We know that the C sharp event is provided by C sharp, namely the Microsoft, because uh, the framework we use is Microsoft C sharp compiler. And there is another version of event which is provided by Unity. We call this kind of event a Unity event. So what is that? Okay, Unity encapsulate everything again for us and made them Unity event. So in short, the purpose of a Unity event is to expose the event into editor. So forget about the test over here. Let me have an example for everybody. I'm just going to delete everything. And I'm going to create a new empty class, temp2. Okay, it's just call it with a attribute name. So let me. So maybe I have introduced before, but let me do it again. We can public a Unity event into the editor, but we have to include the package. So the package is let me using Unity engine events. Okay, the Unity event class belongs to the package over here. So we have to import the package. The package is Unity engine events. So with the help of using that package, you're enabled to use Unity event class in your code. So I'm going to call this event my event. Okay, that's it. A simple declaration. So go back to Unity editor. Watch here, watch here, watch here, watch here. Ta-da, this one, event. This is a really special block of event assignment. You can just assign any event in the editor. And whenever you press the plus sign, you're going to add one item in the area. Add one, add one, add one more. Of course, whenever you press the minus minus button, you're going to remove the last one item or the selected item of this list. So this is a special event that could be seen in the editor. So for my personal habit, if I want a quick prototype, I'm going to use Unity event. If I need a better efficiency, I'm not going to use Unity event. If I need a better efficiency, I go back to use C sharp event. So that's the purpose of these two events. Okay. All right. So go back to the PowerPoint slides. The test over here is trying to explain why we need a Unity event and what's the difference between the two. Okay, next one. So let's have an implementation of the Unity event. So take a look at this paragraph of code. This is an event center. I think we just implement three different classes, right? So one of the three classes is center. So this is it. This is the Unity event version of event center. So we can see that the first different part is that previously we used a delegate to declare our event, right? Now we don't need a delegate anymore because we are switched to Unity event. Great. So no need for delegate. You can simply use a Unity event to declare an event without the help of delegate. Great. Next, we know that for event center, we need subscribe and unsubscribe. So let's take a look at line number 13. So in line number 13, the signature of subscribe has a little bit changed. Again, since we didn't declare any delegate, we needed the help from Unity action to serve as a delegate. Unity action could be think of a very similar things to delegate. Okay, so here we put a Unity action, and the name of the argument is action. We can think that the action, the Unity action, actually is sort of a method. This is correct. Okay. So after we get the action, we are going to bind, we are going to hook the action and to the event. So by call the add listener, we can add a more function to the hook, to the event. So on the other hand, if you're going to unhook or unscribe a method, you can call the remove listener. This belongs to the event class. So the code becomes simpler. Great. Next one, let's take a look at the subscriber. So previously, the method body is living in the subscriber, right? But right now, this time, I made a little bit modification. I know that I can write a method body just like before, but I want to teach more things to everybody to share more information to everyone here. That is a lambda function, a lambda expression. So do you heard this term before? Lambda function? Okay. Uh, don't be scared by the weird name. Okay, lambda is a Greek character, but here it just represents an anonymous function. Anonymous function means it is a function with no name. With no name. This is an anonymous function. So why are we going to use the anonymous function over here? What can it do? Okay, the anonymous function help us to get rid of design a name for it. Okay, at least this is a benefit of it. And we can see that when we are declaring a Unity action, we have to provide the body of the method at the same time. Whenever we instantiate a Unity action for our action, we have to provide the method body at the same time. Since we don't have any named function, we can put an anonymous function as the only argument when we new the instance. So this is the idea. We can see in line number 9. The lambda function starting with a pair of parentheses. If there is any arguments that you designed for this anonymous function, the arguments could be put inside the parentheses. But as you can see in this example, I plan no arguments for this anonymous function. So this is empty parenthesis. And later we see an arrow over here. The arrow is composed of an equal sign and a greater sign. This is actually an arrow. So this is the architecture of a lambda function. And to the right side, you will find a pair of curly braces. Curly braces. Your method body should be put in the curly braces. So here we just see one line of code. The only one line is to printing some log message to the screen, and the message is event handled. So of course, you can have a multiple line belongs to the body of the lambda function. But in this example, I just write one line. Okay. So line number 9 is a lambda expression, and you can see that the lambda expression is fed into the argument of this unity action. We know that whenever we put a new to the class, that means to call the constructor of this class. So we call it the constructor of unity action. At the same time, we pass this lambda function. Hooray, that's it. So we can use the action later. So we can see that in line number 14, we just bind this action to the center by calling the subscribe function. And in line number 19, we do the unscribed thing in the same manner. So that's it. Okay. All right. So that is subscriber. Next, we're talking about the publisher. There aren't too many things modified in publisher. The first is that the publisher must know who is the center. So this part is unchanged. And in line number 11, whenever somebody press a key, I'm going to trigger the event. So I just call the invoke belongs to the event center, and this is unchanged. So for publisher, everything is unchanged. All right. Pardon me, because we don't have enough time to have an exercise on Unity event. We have to move on. Okay. So in the final 30 minutes, we're going to finish the last example in this PowerPoint slides. Okay. So let's go to the example part of this lesson. All right. So we're going to make a character. That character could be moved by your keyboard. So we're going to make a capsule and take the capsule as a character. We're going to put a red box to serve as its eye. So that's the outlook of this character. All right, so let me share how to make this character. Let's go back to the Unity editor. So in the hierarchy tree on your left-hand side, right-click and add a 3D object. This time I need a capsule. Capsule. 3D object. Capsule. Boom. So after you add a capsule, please do remember reset the transform content. So right click in the inspector, select transform and select reset. So the capsule needs to be elevated by 1 unit in y direction. Otherwise, it will be synced into ground. All right, now we have a capsule. So the second thing is to put a red eye for this little guy. So right click in the hierarchy tree, select 3D object, select a cube. So this time, let's reset the cube, and we're trying to make it shown in red color. So how to do that? All right, I need a red material, which could be taken as a red paint. So right click in the as a window. This is the as a window. Right click. Let's create a new scene. Let's create a new material. Okay. Right click over here. Create a new material. New material. So let's call this material a red material. Okay, when you select the red material, we can look at the right hand side. There are so many parameters, but the parameter we're going to set is the albedo. Albedo means the color on the sun. This material will show its albedo when it is shined by a sun. Okay, so select the red color in albedo. Now this is a red color. You can drag the red material onto this, drag this red material onto the cube. So this is how we paint some color into the object. You can make a material and drag the material onto any surface you find in the editor. So now let's shrink down the scale and make it look like a eye of this character. Please do remember that the front is pointing to the red arrow, sorry, the blue arrow. The front is blue arrow. Simple, right? We spent a whole year last year to make these such kind of things. We built some levels. Do you remember? Yeah, yeah, yeah. Okay, so let's assemble everything and make the name correct. The capsule actually is a character, and the cube actually is an eye. And the eye should belongs to a character, so we drag the eye to be a child of the character. So next time you can duplicate character to have more character. So that's it. Oh, in the PowerPoint, I just added a new empty extra root object, but never mind. That could be both of the structure is correct. Okay, next one. Now we're trying to move this character. So let's add a script which belongs to the character. And we call this script an example character with move. So let me explain the code on the screen. In the update API, the update API will be executed 60 times in 1 second, just like we know before. So every time it executes the update, it will distinguish whether the W key is pressed or not. So if W is pressed, we are going to call move and move these little guys forward a little bit. So the same thing happens to when we press S or D or A. Any stroke of these keys will having some response of the character and let the character move into corresponding direction a little bit. So what is move? Actually, move is a customized method which you can find at the below of the class here, line number 25. Here is the remove method. For remove method, you just call the transform to get the position of this little guy, and it's trying to add some vector to the position, and in order to make the position move a little bit. So we can see that the only argument is velocity. We can times the velocity with a small time duration, which is called a delta time. A delta time is actually about 1 over 60. So it's the inverse of the frame per second. So that means whenever 2 frames is shown on screen, the time should elapse for 1 over 60 seconds. So Unity will calculate the elapsed time for you. You don't have to calculate by your own. So you can just by read the value from time dot delta time to get this duration, elapsed time. So this is it. If you copy all the code into the class, you can make these little guys to move. Okay, let's do it. Let's spend about 3 minutes to finish the code over here. Okay, the code on page number 33. what's the problem of the code just written? I mean, oops. So we have some criticism about the code over here. The problem of this we have the problem because we're trying to find two different codes again. One is control and one is representation. We should always separate the control thing and the visual part or the representation part to separate lot of codes. So did I talk about the MVC before? We model, view, and control. Model, view, and control is just a concept to separate different entities into different codes. Otherwise, if you reset, you mash everything together, it will totally get spaghetti code. Because this kind of code spaghetti code. Pretty like all the things are wired together, and you never find where the problem. So you have to separate from line number 24. Separate them into two different classes. So if you agree the concept or the philosophy behind what I talked about, so you are going to separate these two things. Let's see page 35. This is the first thing we learned from this lesson, the direct method code. We can separate these two classes into two different different names. We keep the where's my cursor? Where's my cursor? So here. We keep all the moving things in character with move class. This is how we move the character in order to have some visual effects, right? And we take out all the input get key part into another class. And I'm going to call this new class a method call class because we directly call the method through the reference over here. Do you need to remember that? Okay, now let's refactor everything. We call when you try to remake all the code, we call this kind of task a refactoring. Okay, let's refactor the code. Uh, okay, I'm going to copy all the code in update, cut it, and go back to Unity and add a new class according to the PowerPoint. And make it example character method code. Input manager method code. So input manager. Oh, one reminding for everyone. If you want to modify any part of the code, do not directly modify it. You can use Control R and R again. Control R with twice R, press twice R, and you can refactor the name of anything you choose. And let me refactor the name of the code to input manager. And this will also modify all the parts that related to this term. It will automatically modify the term in your whole project. So this is refactor. Otherwise, if you directly modify all the character by yourself, you will only fix one of the problem. So this is the difference between refactor and you modify the character. So as we can see that if I directly put all the code into the input manager method code class, it will have a missing variable.
it doesn't know um, who has the move method. So I have to declare, sorry, public declare a character with move, and I'm going to call it a char move. Okay, perfect. Now I split all the control things to become a new class. So I'm going to let a virtual controller to holding this class in the game. So I'm going to add a input manager, and also attach the input manager code to its input manager. Uh, sample. So if you like, it has some logo, you can assign a logo to it. Okay, if you directly run the program, you will have a null reference. Why? What is the problem? Did you see that? This is the input manager, and he tries to figure out who's carrying the move function, but he failed because I forget to assign a character to the input manager. So once I assign the character to this code and run again, now he can find who is the character. So this is pretty close to the architecture over here. Hooray! Now I just split the controller and split the character to in two different roles. If we take a very strict attitude to the code, there are still something else. For example, the point because this is the velocity of your movement, it shouldn't be put in an input manager. The velocity should be put in the character, right? This could be a character. We see a character. So never mind, this is just an exercise. Let's not remember. This is the moving velocity. So it shouldn't be belong to the input. Right. So, if your game has more controllable key, and the switch will work. This how it works. And in that time, if you have problem or you are going to reassign any key to different combination, you just go to check your input manager. Everything will be complete. Okay, nice. Right, next one. Well, run out of time. And we can by switching the red method code into send message, we can rewrite everything like this. All right, so now we see there is a send message on this page. So we just changing from the direct method code to send message. And you can find that the argument is different. The argument is boxed into C# object.
Do you remember the boxing and unboxing scenes? Okay, so that means now we have boxed the vector 3 into an object type and sent to the move method. Okay, this shouldn't be a problem. But if you move your character oftenly, this will create so many garbage in the heap, just like we said before. So this is not a preferred method because we put the same method in update, and update will execute for 6 times in 1 second. So this is a little heavy things to do for the engine. But fortunately, not always these 4 keys will be pressed. So just part of the time of playing will make these codes taking effect. Okay. But we are going to skip this. We're going to skip this page. Okay. This is very simple. Let's go to the next page. Next page is use the delegate to refactor the code. So we see that for the character part, we didn't modify anything. The character just keep its original codes. But for the manager part, but the input manager part, this time we are going to assign, we're going to create a delegate, and I'm calling this delegate a delegate move. And let's go to the line number 23. This time I didn't use any reference whenever I call the move method, right? Do you remember for last time I need a reference. I need a reference. I always need this reference. Whenever the reference becomes null, my program just crash or just send me some red error message. This is the same message also needed the reference, right? But for delegate, whenever you bind the delegate to some reference, and from and from here after, you don't need the reference anymore. You can just call the delegate. Okay, so this is the key difference between a delegate and the previous methods. All right, and let's go back to the line number 5. In line number 5, we get a reference. In line number 6, we declare our delegate. So we restrict the delegate to having one argument, and that argument should be a form of vector 3. And then we declare and define our delegate. Declare a delegate, and we define the delegate in enable, and we remove the delegate in disable. All right. So, Mr. Fu, why are you always remove the delegate? Can I just leave it in the memory? Should I must remove all the delegate before the game ends? Yes, you should. And this is one good habit for everyone. And I will explain why you always should remove the delegate and when you don't need it. Okay, I will explain later. So this example is pretty straightforward and easy. We're going to skip it. All right, this one. This one is most important. We're going to spend about 5 minutes to finish this one. Before that, let me explain. This is the fourth time we refactor this part of code. We are switching the whole system into an event system. So in the event center part, we declare a delegate and an event. And of course, we design the subscribe and unsubscribe method. And we also implement the invoke method. And this is everything for event center. And let's now see the publisher. Event center doesn't matter whether you are going to move a character, drive a car, or jump, or any game logic. Event center always do the abstract things. These things are all abstract things. No matter what you actually want to do, these abstract things are unchanged. But for the publisher, it will depend on what key you are trying to deal with. So let's see the publisher part. In the publisher part, again, we use the W, S, D, and A to send some message. So whenever we press W, we just inform the center to invoke some events. But this time, this is not good because we just passed the velocity as an argument. We shouldn't do that. We should put this in the subscriber, but never mind. Okay, the next one. The next page, we see the design of subscriber. The subscriber has the real body of the event handler. So this event handler is the move function, and it just move our character. And of course, our subscriber will automatically enable and subscribe. And when the object is disabled, the subscriber will unsubscribe. So everything keeps the change. So let's take 5 minutes to implement the code, right? From page number 37 to 38. Okay. All right, so this is the last part of this lesson. Whenever you finish the code, you can package everything, and let's call it a day. Okay, so this is what you implement. This is what you implement. This is the control and the characteristic condition is with the after last process event center. And if you have furthermore design for the character, you can just by hand the code here.